Hi class. Today I want us to look at a specific case in quadratic equations. Basically, when you are given a quadratic equation to solve, basically we have three methods. One is called the factorization method. One is called completing the square method, and the last one is by using the quadratic formula. Or simply the formula. All right. And there is one again we can use to solve a quadratic equation. That is what I'm using the graphical method, or basically graph. All right. But today, the 21st lesson for algebra, I want us to be specific here by solving a quadratic equation using factorization method. I believe the 22nd lesson is going to be completing the square method, and the 23rd lesson is going to be quadratic formula. We reserve graph for the last aspect of algebra before we can say we are done with algebra. All right. So as you can see, I already mentioned here that solving quadratic equations by using factorization method. So first of all, you can only solve a quadratic equation by using a factorization method if there are possible factors. It is not entirely about a choice to say, no, I like factorization method, let me use factorization method. No, it has to be possible. Otherwise, you cannot use factorization method. So let me say this one clearly, that factorization method is not a universal method. Unlike completing the square method, we can use to solve whether there are factors or not. Like also the quadratic formula. You can solve a quadratic equation whether there are factors or not. But factorization method is so limited that you can only apply it when there are possible factors. Because we have so many problems, let me don't take much time and see what we do. Okay. First of all, I categorize them. There are three forms you will expect from your examiners, from the question paper, from the teacher. The one is that we have this, and it's also here. When the coefficient of the squared term is 1. So if what is in front of the squared term is 1, that case is different from if the coefficient of the squared term is not 1. Here, the coefficient of the squared term is not 1. Here, it is not 1. Here, you can see nothing is written. It means there is 1. We don't have anything in front here. It means there is 1. Here is 6, meaning not 1. Here is 2, meaning not 1. But how about this? Why didn't I mention this among those wherein the coefficient of the square term is not 1? Well, here we don't have three terms. Mind you, I'm not talking about equal to 0. Okay, here we have 1, 2, 3. Apart from equal to 0. 1, 2, 3. Yes, though 5 comes after the equal to sign, but it is part of it. If you bring this one to the left, it will become minus 5. Okay, but here we have 1, 2. We have 1, 2. These are special cases. So I can say this and this, one category, this is second category, and this is the third category. Let's see what happens. All right, the first one says x squared minus 3x minus 10 equal to 0. Okay, like for beginners, it would be advisable you save the video because this one comprises a lot meaningfully. Okay, now the first thing you do, if apart from equal to 0, if every term is on the left, like this one, if it is not everything is on the left, you have to move everything to the left. So here we are lucky, it appears the way we want it. So what is the next? Try to check if here is 1 or not. If it is not 1, that one is a bit easier. What do we do? Ask yourself this question. What are the two numbers you multiply to give you this? The same two numbers, if you add them or you subtract them, you get this. Well, numbers we multiply to give us 10 are 10 and 1, 5 and 2. There are no other numbers we multiply to give us 10. But the thing is, the numbers we multiply to give us 10 must be the same numbers if we add them or we subtract them to give us this 3. Now, 10 times 1 is 10, 5 times 2 is 10, no problem. Let's try this way. Let us try the addition. 10 plus 1, is it 3? No. Let us try the minus. 10 minus 1, is it 3? No. So it's obvious that this one is not working. Let's try this one, these two again. Let's try the addition. 5 plus 2, is it 3? No. 5 minus 2, is it 3? Yes. So it works. Remember, either you add or you subtract. Any of the two that works, it means it has worked for you. Okay. Now, but this is minus 3 and this is minus 10. So it means we need appropriate signs. Yes, we know that this is the one that is working. And if after assigning the signs, these two do not work again, it means that this equation cannot be solved by using factorization method. How do we give them the signs? What is the first sign here? Let's treat this one to be the first sign. The second sign, the first sign goes to the bigger factor. I'm not saying the first sign goes to the first factor. I'm saying the first sign goes to the bigger factor. Minus as the first sign goes to the bigger. Of course, you know, 5 is bigger than 2. How do we get this sign? You multiply this and this. Minus times minus is plus. So this is. Now I want us to try everything again. Remember, if you multiply to get this. Minus times plus, minus 5 times 2, 10. That is it. Let's try this one. When you come to this, you don't multiply. Call them as they appear. Minus 5 plus 2, minus 3. Are they not the factors? These are the factors. So we open our bracket like this and say equal to 0. So easy. You only struggle a bit in finding the factors. So we say x, we say x. Minus 5 is here, plus 2 is here. But you can choose to write this before this. It doesn't matter. Why? Because minus 5 plus 2, which is minus 3, is the same as plus 2 minus 5, which is the same minus 3. Minus 5 times plus 2, which is minus 10, is the same as plus 2 times minus 5, which is minus 10. I hope you get the point. All right, so we say x minus 5 equal to 0. Then x plus 2 equal to 0. So now we can say x, we move this to the other side and say plus 5. Moving a value from one side of the equation to the other side, the sign has to change. And here x equal to this going to the other side minus 2. So we can say our x values can either be 5 or minus 2. These are the results we get. I hope you understand it. Okay, now I want to use the opportunity to explain why we usually say this equal to this, this equal to 0, this equal to 0, this equal to 0. In mathematics, precisely algebra or equations, we have what to call the AB equal to 0 principle. How do we call it? The AB equal to 0 principle. What does it say? Whenever you have a situation of AB equal to 0, you say A is equal to 0, B is equal to 0. This is the reason all your lifetime dealing with equations, quadratic precisely, you see this equal to 0, this equal to 0. This is called the AB equal to 0 principle. Let's prove it. Why this one is right? Well, if you say AB equal to 0, AB equal to 0. If you want to find B, what do? We divide both sides by A. So A takes away A, this is B. 0 divided by any value is 0. What if we want to find A? We divide both sides by B. B takes away B. What is A? 0 divided by any value is 0. So whenever you have a situation of A being equal to 0, A is 0, B is 0. All right. So I think we don't have much time. Let's go to the second one. If you want to copy, pause the video, then you copy. Okay. Now, before going to the second problem, let us solve another one of the same category. Okay, this is the fourth one. You can write it if you are copying. You can consider it to be your second example. Okay, it says x squared minus 10x plus 25 equal to 0. We want to solve this quadratic equation. But are all the terms apart from 0 on the left-hand side? Yes. All the terms apart from 0 are on the left-hand side. That is good for us. What is the next? The coefficient of the squared term. What is the squared term? Is a term with the variable with a power of 2. This is the squared term. Is its coefficient 1 or not 1? It's obvious. It's definite that it is 1. So therefore, straight away we have our two brackets like this. Okay? What do? We say x, we say x. Now, ask yourself this question. Okay, before we go to that, let me just maintain the same routine of the explanation. What two numbers do we multiply to give us 25? But if we add or subtract, we get 10. What two numbers? First of all, the numbers we multiply to give us 25 are 25 and 1. 25 times 1 is 25. Then 5 and 5. 5 times 5 is 25. Okay. Among these two sets of numbers we multiply to give us 25, which of the sets we can possibly add or subtract to get minus 10? To get 10 for now, let's see. Let's try the addition. 25 plus 1. Can it give us 10? No. Let's try the subtraction. 25 minus 1. Can we get 10? No. So this is not a possible set we are finding. Let's try this one. Let's try the addition. 5 plus 5. Can we have 10? Yes, we can have 10. It doesn't matter if the minus side doesn't work, as 5 minus 5 cannot give us 10. But the fact that one of the two ways works for us, that is all what matters here. All right, so we know that this is the set. But we cannot just endorse that with the set. Let's try and see how we give them signs. Remember, here is a minus sign, here is a plus sign. How do we give them signs? The first sign, remember what I said in the first example. First sign, second sign. The first sign goes to what? The bigger factor. But it's unfortunate here that none of them is bigger, none is smaller, as they are equal. All right. So if they are equal, the choice is yours to give it wherever you want to decide. So I can say this minus comes here. Yes. What do we do here now? We say this times this. The same explanation I did for the first problem. Minus times plus is minus. So this is minus. Can we verify for the last time? No problem. Let's multiply. Minus 5 times minus 5 plus 25. When you come to this, you don't multiply. Just read as you see them. Minus 5 minus 5 minus 10. These are our factors. So we have this one here. X involved, so you have to say X. If it is P, you have to say PP. So minus 5 minus 5. So AB equal to 0 principle. So A, which is X minus 5, is 0. X minus 5 is 0. So X is what? 5. Even if you don't repeat, you know it's the same. X is 5. So when we have a situation like this, we say X is equal to 5. But mostly you say twice. Yeah, mostly we say twice. So when we have a quadratic graph of this nature, remember quadratic graphs, they curve this way or they go this way. But it all depends what is here. If it is positive, like in this case, which way does it go? It goes this way. If it's negative, it goes this way. But having it here as a 5, it means it will cut at x equal to 5. It will not go beyond. But that one, we can discuss that in functions, quadratic functions. All right. So this is what we have. Let's go to 2 and 3 now. I didn't want to have a two separate videos, so I decided to do one for all of this. So the length of the video might be long a bit, but just be patient. All right, the second one says 2x squared plus 9x equal to 5. The first question again, apart from equal to 0, are all the terms on the left-hand side? No, because there is one term which is not on the left. That is 5. Let's bring it to the left. So we say 2x squared plus 9x. When this one comes here, remember no sign is here. It means a plus sign. Moving it to the other side, we say minus 5 equal to 0. The next question again. The coefficient of x squared, or generally the squared term, is it 1 or not? It is not 1. So if it's not 1, we cannot go directly and find the factors. So we multiply the first and the last, the third term. So plus 2 times minus 5 is minus 10. Yes, minus 10. Now let me take you back to the one I just did before coming to this. We said what? Numbers we multiply to give us 25, add or subtract to give us 10. Well, in the case wherein the coefficient of the square term is not 1, you don't say numbers will multiply to give us this, add or subtract to give us this. But the explanation now goes like, numbers will multiply to give us this one. Is that clear? If we add or subtract to give us the same position, but that of the multiplication changes from here to the product of these two. Now, what numbers do we multiply to give us 10? 10 times 1 can give us 10. 5 times 2 can give us 10. Do we have another set? No, there's no other set. These two sets, which of them we can add or subtract to give us 9? Let us try the addition. 10 plus 1 cannot give us 9. Let's try the minus. 10 minus 1 can give us 9. So this one seems, I cannot say it's working, seems to be working. Yeah, let's try this one and see. Of course, these are what we multiply to give us this. So let's try the addition. 5 plus 2, we cannot get 9. 5 minus 2, we cannot get 9. So it's obvious, this one. But the final thing remains for us to endorse that set is by giving the signs. How do we give the signs? First sign, second sign. The first sign goes to what? The bigger factor. 10 is bigger than 1. So plus comes to this. How do we get this? Plus times minus is minus. I hope it is clear. Okay. So if you want to erase this, if you want to leave it like that, but mostly not only 2 times minus 10, but together with x squared. So there must be x squared. But all this is just like a protocol. You don't compose it to even write that. So now, what do? We have our two brackets equal to 0. Please pay attention. We have x, we have x. What are the factors? Plus 10 minus 1. This is what we used to do in where the coefficient is 1 here. This is what we used to do. We say this equal to 0, this equal to 0. But the fact that the coefficient of the squared term is not 1, we don't say this equal to 0, this equal to 0 now. We don't do that. What do we do? Ask yourself, what is the coefficient of the squared term? It is 2. Well, you divide this by 2. You divide this by 2. I hope it is clear. A stage where we used to say this equal to 0, this equal to 0, when here used to be 1, but since it is no longer 1, we don't say that directly. We use this to divide this. Is that understood? 2 is 1, 2 is 5. We cannot simplify this one further. So this one is x plus 5. This one cannot be further simplified. So what do? This 2 comes in front of this x and become 2x minus 1 equal to 0. I hope it's not difficult to do. This is the only difference. Now we can say a equal to 0, b equal to 0. So x plus 5 is 0, 2x minus 1 is 0. Now x is equal to, we move this to become minus 5. 2x equal to, we move this to become plus 1 because this is minus. So we divide by 2 by 2. Here there is nothing to divide both sides. Okay, so our x is minus 5 and this is what is half. So this is the difference when you have something in front of the square term and when there is nothing in front of the square term. Okay, you can pause the video and copy if you want to copy. Okay, so I hope it is clear. Let's go to the next one. I'm sorry for the video is taking much time. Which one is next? Okay, this one. 6x squared plus x minus 1 equal to 0. The first question, are all the terms apart from 0 on the left? Yes, all of them are on the left. The next question, what is the coefficient of the squared term? Is it 1 or not 1? It is not 1. So we cannot find the factors directly unless we say the first term and the third term, we multiply them. Plus times minus is minus. 6 times 1, 6. You can choose to write this one here. Mostly I don't write it because mathematically this is not part of the procedures. So being that it is not part of the procedures, mathematically it's not compulsory to indicate that x. Yeah, it's just a procedure. Okay. So now what are the numbers we multiply to give us 6? Add or subtract to give us this one here. There is one here. Well, numbers we multiply to give us 6 are 6 and 1, 3 and 2. No other set of numbers. So what is next? Let's see. Which of these sets we can add or subtract to give us 1 here? Let us try the addition. 6 plus 1 cannot give us 1. Let's try the minus. 6 minus 1 cannot give us 1. So this is not the set. Let's come to this. We try the plus. 3 plus 2 cannot give us 1. How about the minus? 3 minus 2 can give us 1. These are the sets. But will be endorsed fully after giving them the appropriate signs. All right, so let's check now. First sign, second sign. The first sign is plus. It goes to where? The bigger factor, which is 3. How do we get this sign? Plus times minus is minus. Okay. So now what do? We have our two brackets like this, equal to 0. So we have x plus 3 minus 2. You can choose to write this before this. It doesn't matter. So can we say a equal to 0, b equal to 0 now? No. Why? Because there is something in front of the square term, which is 6. So we use that 6 here. I hope it is clear. 3 is 1, 3 is 2. 2 is 1, 2 is 3. But we need what? A single number. If it is not a single number, the lowest you can get is a fractional value. The denominator comes in front of x here. So it becomes 2x plus the remaining one. So 3 comes here. Yeah, so 3x minus the remaining one here. I hope it is clear. So therefore, now we can say 2x plus 1 is 0. 3x minus 1 is 0. So 2x is minus 1. Then 3x is, this one moves, plus 1. Here is 2, we divide both sides by 2. Here is 3, here is 3. So x here is minus half and x here is half. I hope it is clear. Now let's go to the last two. If you want to copy, pause the video, then you can copy. This could be one of the longest videos I have made, just that I don't want to have separate videos. In one package, you understand everything. All right, so 5 and 6. Of course, these are so easy. 4x squared minus 9x is 0. Okay, well, maybe I can have 2, okay, minus 9. Now, let us compare the two. Here, 2 terms apart from equal to 0. 2 terms apart from equal to 0. But what is the difference? Apart from the term with the square, this term does not contain this x. Apart from the term with the square, this term contains this x. So there are 2 different cases. Yes. So how do we solve them? Well, this one has 2 ways to do it. This one has only 1 way, basically, to do it. So what do we do here? Let me give you 2 methods. This is 1, this is 2. The first thing you do is to say 4, but most often, this one is a perfect square. If it's a perfect square, you can do it this way. This 4 is what? Is 2 squared x squared. Or because of the size of the video, let me just leave that method. I think that one will be like third method. Okay, let me just apply this easy one. We can say 4x squared equal to, move this to the other side, in a situation wherein the second term does not contain this variable. So we divide both sides by 4 by 4. This takes away this. So this is x squared 9 over 4. Yeah, there is no x here, only here. And this x has a power 2. So we ignore the square and take the square root of the other side, which is 9 over 4. Observe how my square root is, it goes down just to cover the denominator. This one is a quadratic equation. Why? Because the highest power is 2. So forcefully we need 2 values. So we have to say plus or minus. So x is plus or minus. Square root of 9 is 3. Square root of 4 is 2. So x is either plus 3 over 2 or minus 3 over 2. Is that understood? What is the second method, the other method I was trying to avoid? Well, you can say 2 squared x squared minus 3 squared, which is 0. 9 is 3 squared, 4 is 2 squared. This term contains 2 squares. We can unify that by writing it like this. Minus 3 squared, 0. Difference of 2 squares. The first minus the second. We repeat again the first, but a plus now, plus the second. Yeah, this term minus 3 equal to 0. The remaining a be equal, the remaining a be equal to 0 principle. 2x plus 3 is 0. So 2x is, we move this to what? Plus 3. 2x, we move this to minus 3. So divide by 2 by 2. X is 3 upon 2. Divide by 2, divide by 2. X is minus 3 upon 2. Just the same result we get. So whenever there are 2 terms only to a quadratic, and the second term there is no variable, this is what we do. What if the 2 terms only we have apart from equal to 0? This one has x, this one has x squared, and that one is even easier than this one. Let's see. The length of the video might be longer than you're comfortable, but never mind. Oh, this is 20x. All right. There are 2 terms only apart from equal to 0, and both there are x. X, but this is x squared. What do we do? Go to the numbers. Is there anything common? In fact, you can even forget about the numbers. Focus only on the variable. X squared, x. What is common? X. X takes away only one x. There will remain 5 and 1x because this x takes away 1x. So minus x takes away x, leaving what? 20 equal to 0. This is also part of A, B equal to 0 principle. So you say x equal to 0, 5x minus 20 equal to 0. So we say 5x equal to, we move this to become 20. This is 5, this is 5. So x is what? Is 4. So our x is 0 or 4. Mind you, this one is a quadratic equation. So it is forceful that we have two values. Okay. Now, there is a misconception here. So many students or some beginners, they have this mistake I want to explain now. What they do is, if they have 5x squared minus 20x equal to 0, what they will do is, they will say 5x squared equal to, they move this 20x. They divide by x, they divide by x. X cancel x, x takes away 1x, leaving 5 with 1x equal to 20. Divide by 5, divide by 5. So x is 4. This one is a big no. This one is a big no. Please refrain from that. Thank you for watching. Don't forget to follow, like, share, and comment. Also subscribe to my YouTube channel. See you in my next video.